Welcome or welcome back at C Squared. In this lesson we'll talk about first area of a circle and then we'll talk about the area of a sector. And if you notice here, the area of a circle, which I call it A, is equal to this product pi r squared, where r is the radius. Another thing that I want you to be aware, area means what is inside. Okay, so like a pizza is the whole pizza. Since the circumference, be sure, means you go around. So this is the area, and like I said, there is one formula, pi r squared, where the radius is r. So let's see an example. In fact, two examples, this one, A and B, and we need to find the area of circle T in the first one, where TB is 10. TB is, if you notice, the radius. So this is just the formula I mentioned a minute ago, pi r squared. In this one, I'm going to replace r with 10 and 10 squared. Following the order of operation, 10 squared is 100. So that is the answer. And we're going to leave it in terms of pi because that's what it says here. In case you need to approximate, you're going to need a calculator and approximate based on how you are asked. On the second part, very similar question. However, now if you take a look, we have EF. EF now is the diameter. You see, this is the longest chord. It goes here through the middle. So the first thing I'm going to do, I'm going to find the radius. The radius is half of the diameter. So in this case, we have this 24 divided by 2, and we end up with 12. So now we can move to the last part. We're going to use the same formula, pi r squared, where I'll replace r with 12. So pi times 12 squared, very similar. Order of operation, 12 squared is 144. Pi, this is the exact area. If you need an approximation, like I said, a calculator, and see how you approximate. On this second example, we will see an application of the area of a circle. We see John here wants to cover his circular hot tub with a made cover, and that hot tub has a diameter of 8 feet. So I'm gonna make a short sketch here. This is what we have, and this is 8 feet. Okay, so the first thing you want to do in this part A is to find the radius, which is the half of the diameter, like in the previous problem. So in this case, we have 8 divided by 2, and that will be 4 feet. Now we can move to the last part of part A, find the area. Again, the same formula, pi r squared. We're going to replace r with 4. So pi times 4 squared, and we have here 16 pi, and I'm going to write the unit here, square feet. Okay, that is the area of this hot tub. Of course, if you need to approximate, you can do 16 times pi. You are not asked here, so let's leave it like that. Okay, so now let's take a look to part B. Find how much will cost John to cover his hot tub if a square foot of that cover costs $3.50. So that is very important. A square foot costs $3.50 because that's probably the thing I will start with. 1 square foot of that cover costs $3.50. 3.5 is the same thing. So you notice this is my first part on this proportion I'm going to write, and then on the second part we're going to write what? The area of the hot tub, 16 pi square feet over how much is going to cost X. Okay, you notice I put the units. It helps me to be consistent, to write the correct proportion. Now I can erase them and I can use cross multiplication. Of course, some of you may say it can be done in a different way, which is correct, yes. And here we have 1 times x equals 3.5 times 16 pi. So 1 times x is just x. So now we're going to grab a calculator and do the math. You see there, 3.5 times pi times 16. And I end up with 175.929. I'm gonna copy the first 3 decimal. Of course, this one means dollars, and I'm gonna round it to the nearest cent. So it's gonna be $175.93 for that cover, hot tub cover. Okay. Here on the next example, we're gonna go backwards. If you notice, we have the area of the circle is 225 pi. Can we find the diameter? So we're gonna go and write A equals pi r square, and now the area is known, so it's 225 pi, and that will be equals pi r square. So this is an equation. Remember, pi is a number, and the first thing you want to do is find r square. So I'm going to divide by pi to cancel this pi. The same thing I'm going to do on the other side. I'm going to cancel this pi, lucky us. So sometimes if the area is given in terms of pi's, don't do anything, leave it like that, because the pi will disappear. So we have r squared equals 225. How do we find r here? We need to take square root. Since the radius is a positive number, I'm not going to put plus and minus, and square root of 225 is 15. 15 inches. Remember, we have the units of square inches here, so this is going to be just inches. So now how do we find the diameter? The diameter will be twice the radius, 2 times radius. So that will be 2 times 15, and that will be 30 inches. Okay. This is the second part of the lesson. We're going to move to the sector of a circle. You notice that is what we call a sector of a circle. So I mentioned at the beginning of pizza, the whole pizza. Now this one is a slice or more than one slice. Okay. How do you find that area? You have two choices. One is to use proportion, which I like it and I use it. This one, proportion, and this one, if you remember, if you want to use a formula, this is a formula that can be used. A is the area of the sector, and this represent the angle, the central angle, how we call it. So let's see an example. In fact, 2 examples, and on the first one we need to find the area of the sector that has a central angle of 60 degrees. The radius, you notice, is 10. So my first thing always, if I want to use proportion, is to find the area, and the area of the whole circle is pi r squared. We did that just a couple minutes ago. So in our case, it's going to be pi times 10 squared. We just did this math a couple minutes ago. That will be 100 pi. This is the area of the whole circle. And now I'm going to use proportion, and I'm going to go down here and I'm going to say, hey, the area of the circle is 100 pi, but that means the whole circle, which means 360 degrees. And I want to find the area, so I'm going to call it X, but you can call it A if you want, of that sector, and that sector is just 60 degrees. Okay, you notice how the proportion looks like. Now I can raise this degree here. I'm pretty sure I'm consistent. I'm going to do cross multiplication like we did before. So we have this cross multiplication, and we have 360 times X equals 100 pi times 60. The last step to find the X, the area of the sector, divide by 360 to cancel this 360. And we have X equals, or the area of the sector, let me write like this now, is this expression 100 pi times 60 over 360. Here you can simplify. 60 goes in 366 times, and we have the area of the sector will be 100 pi over 6. And in fact, you can get this area just look into this value and think about how many pieces like this you have in this circle, and you have 6 of them. That will be an easy way to do it, the fastest way in this case. Here we can simplify by 2, and we have 50 over 3. 50 over 3, don't forget a pi, and we're gonna leave it in terms of pi. The area of this sector is 50 pi over 3. Very similar for the second one. By the way, for part B, there is no shortcut like in part A, where you could have divided just by 6. And you know what? This is the area of the circle, and this is the area of the sector. Let's be sure we have a different A here. So the same thing here, we're gonna find the area of the circle first, which is gonna be pi r squared. In this case, pi times 20 squared, so that will be 400 pi. And this is the area of the circle. And now we're gonna write proportion like we did before. We're gonna have, and I'm gonna try to be consistent. By the way, it's not the only one to write proportion, but I'm gonna try to be consistent. And I have the area of the circle, that is 400 pi in this case. That means 360 degrees the whole circle. And now the central angle is 110, and I need to find that. Again, I'm gonna call it x, but this x, remember, means the area of the sector. But it makes, for me at least, easier to see the equation. Again, we don't really need the degrees here. We're gonna do the cross multiplication, and we have very similar. 360x equals 400 pi times 110. We're going to divide by 360. And now I'm going to replace that A with area of the sector. And now here I'm going to copy, and I'm going to try to simplify. And I think the first thing I'm going to do, I'm going to cancel this 0. And then let me copy one more time. And we have 400 pi times 11 over 36. So now here, if you take a look, we can divide by 4. And in fact, even by 4. And that will be 9. And here we have 100. So they have a common factor of 4. We simplify by that. I don't think it's anything else yet. So we've kind of finished. The area of the sector in terms of pi will be, let me write that as like a sub s down here. So the area of this sector will be 100 times 11. That will be 1100 pi over 9. Okay, if you need to approximate, use a calculator. Very similar with the previous problem, where we have the area of the circle and we need to find the characteristic of the circle, the diameter, I think it was. Here we have the area of a sector, which is 25 square feet. And we know it corresponds to 72 degrees. Can we find the area of the circle? So if you remember, we have the area of the circle, which goes with 360 degrees, equal, so this is the left side of the proportion, equals of what? The area of the sector, 25 square feet. And you know what, I should write here square feet just to be sure you are consistent. 25 square feet over 72 degrees. This is the proportion will help us. And again, now we can erase these units. We know we wrote the correct proportion. So now we're going to do cross multiplication. So we have the area of the circle, the one we need to find out, times 72 equals 360 times 25. We're going to have to divide by 72 left side to get rid of this 72. Obviously, we're going to do the same thing on the right side. So the area of the circle will be this expression. I'm going to try to do it without a calculator. 360 and 72, they both are divisible by 6. So if we divide 72 by 6, we get 12, and here we get 60. Oops. In fact, we can even do a better job. So we have here 60 times 25 over 12, and 12 goes in 65 times. So we're gonna have here left only 5 times 25, which is gonna be 125 square feet. This is the area of the circle, for which the area of a sector that is 72 degrees is 25 square feet. Now we're gonna look to some problem involving area of circle. You notice we have two circles, two concentric circles. They have the same center. It's somewhere here. One is small, one in the middle, and the other one is large. We can see, in fact, this 18. Okay, this 18 is the diameter of the largest circle. Well, the first thing I want to do is to find the diameter of this small circle. So I guess I'm gonna draw this diameter, one of them, one of the many you can draw, and we need to find how long that is. Okay, now if I do the other piece here, that one will be nothing else than 2, and then I can write this statement here, 2, let's say this is this 2, plus this red diameter, let me say d sub 1 for the first circle, the one in the middle, plus the last 2. If we add these 3, what do we get? We get the big diameter of the second circle, which is 18. Okay, let me write that here because we're gonna need that also. This is the large circle. So here we can find d1. We're gonna have 4 plus d1 equals 18. We're gonna subtract 4, so that gives us 14. The diameter of the small circle is 14. Since we talk about areas, shaded region, we want to find the radius for each circle. So for example, here the radius is gonna be, and I'm gonna call it R2, the diameter 18 divided by 2, and that will be 9. Very similar here, the radius of the small circle is gonna be 14 divided by 2, and that will be 7. So now we know what we need for finding the area of these two circles. We know the radius of each circle. Okay, like I said, this is gonna be 7, and this is gonna be 9. Okay, so we can move and find the area of each circle. So in this case, I'm gonna call it A2 is gonna be pi r square, R2 square, and that will be in our case pi times 9 square, and that will be 81 pi. and this is the area of the larger circle, the one with radius of 9. I'm going to do very similar here. I'm going to find the area of the small circle for now. A1 equals pi r sub 1 square, and in our case this one will be pi times d7 square, and that will be 49 pi. One more step to find this shaded region will be to subtract them, right, from the large circle, 81 pi. We're going to subtract 49 pi. So we can leave it in terms of pi. Just need to do one subtraction, 81 minus 49. That will be 32. 32. Don't forget a pi. If you need to evaluate this, of course, a calculator and use that pi. So the shady region is 32 pi. This problem, very similar. You notice we have a shaded regions, but now we do not have two circles. We have a circle and an inscribed polygon, how we call it, a polygon that is inside of the circle. But we notice we have this 16 here, and the problem is going to be very similar for some reason. You'll see it. I'm going to find the area of the circle because that is the first step, and it's an easy one, pi r squared, and that will be pi times 16 square, and that will be 16 square, that will be 256 pi. Okay, so this is the circle. We need to find the area of this regular polygon. This is an hexagon. Okay, and I'm gonna use this way. There is a formula, but I'm gonna use this way in this case. We have how many triangles like this here? We have 6, if you notice. And all these triangles, in fact, are equilateral triangle because each angle is 60 degrees. 360 going around, divide by 6. That will be 60 degrees. So let's draw one triangle like this. Okay, these two are congruent because they are the radii of the circle. This is 60 degrees, so that means in fact these two angles are 60 degrees also. So we have an equilateral triangle. It's even better, I guess, because now what can we do to find the area of that right triangle? Remember, this is 16. If this is the height of one of the triangle, it's gonna go in the middle. This is gonna be 8 and 8 because remember this is an equilateral triangle. This is 16, 16. Obviously this is gonna be 16, and this is 60 degrees. You have choices here. I'm gonna use the special right triangle, which we have 30, 60, 90, and this height will be the longer leg in that right triangle, and it's going to be this 8 square root of 3. Okay, if you do not remember this special right triangle, use Pythagorean theorem. This a squared plus b squared equals c squared. This is going to be a, this is going to be c, and you're going to have to find b for the example. But that's the easiest way if you remember the special right triangle. The height will be 8 square root of 3, so the area of one triangle is going to be what? 1 over 2, and I'm going to write that here. Area of a triangle is 1 over 2 base times height. So 1 over 2, the base is this base, which is 16, and the height we just figure out, 8 square root of 3. So I think I will simplify here. That's the easiest way. And we finish with the area of one triangle. 8 times 8, 64 square root of 3. Now, how many triangles like this one we have? We have 1, 2, 3, 4, 5, 6. Okay, so the area of the hexagon, which I'm going to call it AH, is going to be 6 times 64 square root of 3. So let's do that math. 6 times 64 is 384. And don't forget the square root of 3. One more step. What do you think we need to do to find the shady region? And if you said, hey, I'm gonna have to take away from the area of the circle the area of the hexagon, that's correct. That's what you have to do. And that will be 256 pi minus 384 square root of 3. I'm going to leave the answer exactly like that. There is no possible simplification. If you need to evaluate, use a calculator, and you should be fine. My last problem in this lesson will be another application where we have Michael having a cake, and he's cutting the cake and he gets this big slice of 110 degree. The rest stay with his parents, two parents, two sisters and a brother. So we have 5 more members. Okay, and they will share this. The question is, what is the area of each one receives? Okay, so this problem can be done in more than one way, but my first thing will be to do this math. 360 degrees minus 110, and that will be 250 degrees. So what is the meaning of that? That it means this angle here is 250 degrees. This is the leftover, right? Michael is gonna eat that big slice and the other 5 members are going to eat this. Since they get the same amount, how do we get how much is one slice? You're gonna take that 250 and divide by 5, and that will be 50 degrees. So each member get a slice that the central angle is 50 degrees. That's the thing we need to find out. We need to find the area of a sector for which the central angle is 50 degrees. So that's the first thing. So now I'm going to move and find the area of this cake, which is a circle, and that will be pi r squared. And we notice the third times this 10 has a radius. So no surprise, we have 100 pi here. And if you want to put the units, square inches. But this is the first part, because now we're going to move to proportion, right? If you remember, the area of the cake, the circle, is 100 pi square inches. Again, I'm going to be consistent and I'm going to write the units just to be sure I am consistent. And that is 360 degrees. Now we need to find one slice. I'm going to call it x at the beginning, and one slice is, if you remember, 50 degrees. One more time, that was found here. So again, cross multiplication. Let me erase the degrees and the square inches here. Cross multiplication like we did before. So we have 360 times x equals 100 pi times 50. So again, this way and this way. We're going to divide by 360 to get rid of this 360 on both sides. And I'm going to move here, area of the sector, I'm going to call it now, right? Let's go back to this notation. The x, that is the meaning, is going to be 100 pi times 50 over 360. Since here we are asked to approximate to the nearest square inch, I'm going to use a calculator. Of course, you can do some simplification. I'm going to do 100 times pi times 50. I would suggest you to click enter and then divide by 360. So I end up with this value, 43, and we need the nearest square inch, so I have 43.6, and that means we're gonna round it up, and that will be 44 square inches. That is how much each member of the family gets from that cake. If you enjoyed this lesson, don't forget to click the like button and come back on C-Square for more help. Thank you.